completing the square. If you're watching this because you are taking one of my courses, pre-cal especially, we're doing this to make sure we're prepared for using it as we move into conics later on. Now, if you're not one of my students, that's fine. I promise this will just cover completing the square all by itself. It'll be helpful if you need information about it. Completing the square is most often used to solve quadratics that are not factorable, and it's a way we can solve them without using a calculator. Excuse me. And there are other things they can be used for. There are times, like with conics, that they're helpful in rewriting things to put them in a new form for us. But when it's most often used, at least in high school math, is to solve quadratics that are not factorable. So here's our first example. M squared minus 8m plus 10. Now, this I don't believe is factorable. There's nothing that would multiply to equal 10 that would add and subtract to negative 8. So we could use the quadratic formula, but that's a pain. So we can instead use completing the square. The first step with completing the square is to get the constant, in this case the 10, by itself. So we want to subtract the 10 from both sides and get m squared minus 8m equals negative 10. So that's always the first thing you want to do. Make sure the constant is off by itself. You want it on the other side of the equation from the variables. Next is the part where we are actually completing the square. To do that, we look at the coefficient in front of the m. It's the coefficient in front of whatever variable is raised to the first power. So it might be x or t or n in another equation, but here it's m. And here's what we do. We take that number, we divide it by 2, and then we square that number. So we get 16. Once we get that number, we add that number to both sides. And just a couple side notes there. Make sure you notice you're always going to be adding a positive number because once you square it, it's going to be positive. And if you're plugging those numbers in your calculator, make sure you put parentheses around the negatives, just the way I wrote it, negative 4 in parentheses, then squared, or else you'll get an incorrect answer. So we end up with m squared minus 8m plus 16 equals 6. So now that we've gotten to this point, we can factor the left side of the equation. We need to figure out what would multiply to be positive 16 and add up to negative 8. That would be negative 4 and negative 4. So you may notice that it's the exact same thing in both parentheses. It's the same term, m minus 4, m minus 4. So we can write this as m minus 4 squared. And that is actually why it's called completing the square, because by adding the 16 to both sides, we're making it possible to factor this in such a way that when we do it, both terms are identical and can be written as a squared term. So that is the square we're completing. Now that we've done that, we can solve for m. We'll take the square root of both sides, and when you do that, make sure you put plus or minus in front of the square root. And then add 4 to both sides. So we get 2 possible values for m. 4 plus the square root of 6 and 4 minus the square root of 6. Now my students, please make sure you do leave it in terms of the square root of 6, because I don't want the decimal approximation. It is more exact to leave it as the square root of 6. One other note I want to make when you're doing this last step: if you were to here add 4 to both sides and write it this way, that is still mathematically completely correct. But mathematicians, for whatever reason, just almost never write it that way. They almost always write it the way I'm circling. They put the plus or minus in the middle. I don't know exactly the reasons why they did it that way, but I know one thing is it's helpful to just have the square root on the back side, because then it's easier to tell where it starts and where it stops. You don't have anybody accidentally writing something like this and you're not sure if the plus 4 is inside the square root or not. But for whatever the reason, The way I will always write it, and the way I'd recommend you also write it, is with the plus or minus in the middle of the two terms. Now here are the steps for completing the square. Step number 1. If necessary, divide to make sure a being the coefficient in front of the squared term. So in our previous example, it was the m squared. So a is the coefficient in front of the squared term. So in fact, let me just write the general equation. Make sure it's all clear. So the a, the b, and the c are the coefficients. A is the coefficient in front of the squared, b is the coefficient in front of the variable raised to the first, and c is the constant. So step 1 is, if necessary, divide to make a equal 1. It was equal to 1 in our first example, but we'll look at some where it's not. But the first step you need to do is divide everything by whatever number is in front of the squared term if it's not 1. Second, which we did do in the first example, is to move the constant to the right side. So the number all by itself, the constant, needs to move all by itself. Usually the way it's written is to the right side, but it needs to be away from the variables. Then you add b over 2 squared to both sides. So you divide the b by 2, then square it, and add that number to both sides. You will then factor the left side, write it as a squared term, because it should be the same thing for both, and then solve for x. Don't forget to put the plus or minus in front of the square roots when you do that. So I'm going to pause just a moment just to make sure you have time to write this down if you need to. So now let's apply these same steps to this equation. So step 1, we've got to make sure that a, the coefficient in front of the squared, is 1. And it is. There's just an understood 1 right in front of the x squared. So step 1 is already good to go. Step 2, we need to move the constant over to the other side so it is by itself. So we'll add 22 to both sides. Then we'll take the b, the term in front of the x, divide it by 2. So 8 divided by 2 is 4. And then square the 4, we get 16. So we'll add 16 to both sides. Step 4 is to factor the left side. So we need things that will multiply to be 16, add up to positive 8, so that'll be plus 4 for both of them. That can be written as x plus 4 squared is equal to 38. Now I want to pause here and show you one thing that can actually save you a step. Most of the time you can jump from this step to this step. Okay, for one thing, that's because we're completing the square. You know it's going to be the same thing squared. And I want to show you one little hint. Now this trick doesn't work with all factoring. It just works with completing the square. But if you notice, what ends up right here is the same number we got here. So when we're factoring, it turns out that the number we have is always identical to half of the b. If you look back at our first example, we ended up m minus 4. And when you divide negative 8 by 2, you get negative 4. So that can be a really quick way to factor these when you're completing the square. But let me say it again. This is not some magic trick that works for all factoring. It's just something that works with completing the square. But now that we have it factored and set equal to 38, we do our last step, which is to solve for x. So I'll take the square root of both sides, writing plus or minus in front of the square root, and then subtract 4 from both sides. Notice I do write it at the front end to keep that plus or minus in the middle. It's not mathematically necessary, but that just is the way they always do it, keeping that plus or minus in the middle. Okay, 2 more examples. This first one finally has us doing something about step 1. We have a coefficient other than just 1 in front of the squared. So we have to divide everything by that number. So this one is going to be a little bit trickier as far as the numbers we're dealing with, but bear with me, you'll do fine. First step is to divide everything by this 3. We cannot complete the square if there's a coefficient other than 1 in front of that squared term. So we end up with n squared plus 20 over 3n plus 12 equals 4/3. So we've completed step 1. Step 2, we need to get the number, the constant, all the way over to the right side. Notice there are 2 constants here. There's the 4/3 and the 12. We just need to combine them by moving the 12 over to the right-hand side. Alright, let's see. 4/3 minus 12. You get negative 10.667, or if you prefer the fraction, I think I'll deal with the fraction for now, negative 32/3. Okay, now I need to look at the number, the b, the coefficient in front of the n. I then divide it by 2, so 20 over 3 divided by 2 is 10/3, and then square both sides. We get 100, not both sides, sorry, square the term, so we get 100 over 9. So we'll add 100 over 9 to both sides. Just to make sure you see how you can do one like that in your calculator, because that's obviously a little trickier than just the 8s we were dealing with before. But we would have 20 over 3, and then divide that by 2. You can see that is 10/3, and then I square that. It gives me 100 over 9. So I need to do negative 32/3 plus 100 over 9. And I get, I think that's 4/9. Yes, I get 4/9 on the right side. So this side is 4/9. And I'm going to go ahead and just skip to that last step on this one, because I know once I factor this, it's just going to be half of this number, which is 10/3. So this will be n plus 10/3 on both sides, or excuse me, on both pieces, nope, let's try to get my words right. Inside both parentheses when we're factoring, that's what I'm trying to say. So that's why we can just jump straight to n plus 10/3 all being squared. Because if you factor what we had, it would just be n plus 10/3 times n plus 10/3. Finally, we solve for n. We take the square root of both sides. Gives us plus or minus the square root of 4 over 9. And then we subtract 10/3 from both sides. Also notice on this one, these numbers actually do have even roots. The square root of 4 is 2, the square root of 9 is 3, so we can actually write the answer this way. I'm completely fine with the answer being left that way, but since there's no square root anymore, it's also okay if you wanted to say negative 10/3 plus 2/3 is negative 8/3, and negative 10/3 minus 2/3 would be negative 4 once you reduce it. So you could also write the answer that way, as those two answers. As far as my class is concerned, either way would be fine. Now I admit that one was a trickier one. I believe this last example is still going to make us divide, and I think it will also actually be tricky here too. But we will press on. This is our last example. Step number 1, we divide everything by 3 because we've got to make sure the coefficient in front of the n squared is just 1. We get n squared plus 7/3 n plus 7/3 equals 0. Step 2, we need to subtract the constant, the 7/3, over to the other side. And then we need to cut the 7/3 in half. So 7/3 over 2 will be 7/6. Then we square both sides and we get 49/36. So we need to add 49/36 to both sides. That gives us n squared plus 7/3 n plus 49/36 equals negative 7/3 Sorry, my calculator is doubling everything I do. Let's try one more time. Negative 7. Oh, nope. Hold on just 1 second. Alright, won't use that. Negative 7/3 plus 49/36, negative 0.97222, or negative 35/36. I think... yeah, okay. Now we need a factor. So we get n plus, and we know it's going to factor to be exactly half this number. So we get 7/6. So now that we've finally gotten this far, we can try to solve for n. But we run into a problem. Take the square root here. It's the square root of a negative. So we're going to have to deal with imaginary numbers here. Imaginary numbers. I know, so much fun. So on the left side, the square root and the square just cancel each other out, leaving us n plus 7/6. Over here, the square root of negative 1 is I. So I do have to put plus or minus, and I put an I out front to replace the negative. And the square root of 35, I'm going to say over 6, because the square root of 36 is 6, so I can simplify that part. My last step is to subtract 7/6 from both sides. So there are times where there's no real solutions. So there's no real solution to the original we had there, n squared, or 3n squared plus 7n plus 7. And when that happens, we have imaginary answers. So the only difference in how you solve this, though, is when you have a negative inside the square root, you bring it out front as an I, because I is equal to the square root of negative 1. So that completes completing the square. Forgive me, pun not intended.